Organic chemistry, as tested between the years 2013 and 2017 in Chemistry Paper 1 at KCSE. Welcome. We start with 2013 KCSE Chemistry Paper 1, question number 7. We are told to study the flowchart below and answer the questions that follow. So we obtain an organic compound here with the formula C2H2. If we were to draw the structure, we realize that this is ethene because it only has 2 hydrogens and 2 carbons. It is worth noting that we are supposed to have triple bonds between the 2 carbon atoms. So this is ethene. Ethene is normally obtained when we react water with calcium carbide, and calcium carbide now becomes our substance X. From here, we are introducing 1 mole of hydrogen chloride, not excess. And for that matter, our ethene will only break 1 bond. And when we do so, we shall have 2 pairs of electrons that can take part in bonding here and here. And from our other reagent HCl, 1 hydrogen atom would attach itself here and the chloride atom on the next carbon. So we end up forming what we call chloroethene. That becomes our substance Y. You can call it 1-chloroethene or simply chloroethene. Then from Y, we make it undergo process Z to get now a polymer which we call polyvinyl chloride. Chemical name is simply polychloroethene, which you realize is also called PVC for polyvinyl chloride. So we have studied our scheme, and now it is time to look at the questions that were asked about the scheme. First question, we were asked to identify X, and X, we have agreed, is calcium carbide. When you are told to identify, you can give us the name in words, or we can also give the name in symbols. This would earn ourselves 1 mark. Y, we've agreed, is the monomer that gives the polymer polyvinyl chloride. So a candidate could give the chemical name chloroethene, or we could accept vinyl chloride as well from the name of the polymer given here, for 1 mark. Last question asked us to state 2 uses of our polymer polyvinyl chloride. Polyvinyl chloride is used to make floor tiles. We also use it to make raincoats. We also use PVC to make plastic bags, and we also use it to make hose pipes. We are asked to any of those 4 for half mark each to give a total of 1 mark. We now proceed to the year 2014, question number 7. Draw and name the isomers of butane. Butane is an alkyne with 4 carbons in a straight chain. So we would start with the first isomer, where the triple bond would be placed between carbon 1 and 2. So that is where we shall position our triple bond. Then we complete the structure by introducing the other hydrogen atoms. So this becomes our first isomer, and we call it but1-ine. Next is to change the position of the triple bond from between carbon 1 and 2 to now between carbon 2 and 3. That way we shall obtain the next isomer that would have the following structure: 4 carbons still on a straight chain, triple bond now between carbon 2 and 3, and then we complete the structure by putting in the other hydrogen atoms. This now would be but2-ine. It seems these are the only 2 possible isomers that we have for butane. The structure, half a mark, correct name half a mark. Second structure, half a mark, second name half a mark, to give a total of 2 marks for that question. Next, we are asked to state one use of polystyrene. Polystyrene is also called polyphenylethene. So polyphenylethene is normally used to make insulation materials. And we also use polyphenylethene in making sealing strips. We are asked just one, so a candidate would choose between those 2. Next question is still within the year 2014, and this time round it is question number 23. Study the flowchart below and answer the questions that follow. So we have an alkanoic acid here by the name propanoic acid reacting with an alkali sodium hydroxide. So step 1 is actually a neutralization reaction because we are reacting an acid and an alkali. So when we do these, we get a salt that is called sodium propanoate. Then in step 2, we obtain ethene from sodium propanoate, meaning that the other reagent we need in step 2 is actually soda lime, or we can say a mixture of sodium hydroxide and calcium oxide. Remember, this is an alkane with 2 carbons, ethene. For us to prepare an alkane with 2 carbons, we need to react soda lime with a sodium alkanoate that has 3 carbon atoms. The name would be sodium propanoate. So up to that point, we are through with studying our flowchart. We now move on to answering the questions that followed. Name the process in step 1. Here, neutralization. It is always very easy to answer these questions when you have completely and accurately studied the scheme. 2, we are asked to identify the reagent in step 2, soda lime, or we can say a mixture of sodium hydroxide and calcium oxide. Quite easy for 1 mark. Then we are asked lastly for that question 23 to give one use of ethane. So ethane has so many uses. First one being as fuel. Then we can also use ethane in production of hydrogen. And then I'm also told ethane can also be used in production of an alkene by the name ethene. This we do. I know this is going to be some news to our learners, but please take note, we can obtain an alkene from an alkane, like in this case, through what we call steam cracking. In steam cracking, we expose our alkane to extreme pressure and temperature. The only drawback for this process is that we produce a lot of carbon dioxide, which we know is a greenhouse gas. Next question is number 26, still from the year 2014. Cotton is a natural polymer. We were asked to state one advantage and one disadvantage of the polymer. Advantage is that it is biodegradable, so it will not pollute our environment. Disadvantages seem to be more than advantage. The very first one being that compared to artificial polymers, natural polymers happen to be very expensive. Number two, we are not able to easily recycle the natural polymers. And finally, natural polymers happen to be more prone to effects of acids and alkalis. We were asked only one, and a candidate would pick among the 3 disadvantages that we have just given. We move on to the year 2015 now, and we have a look at question number 1. Give the name of the first member of the alkene homologous series. Very easy question. The first member of the alkene homologous series has 2 carbons, and we call it ethene. Next, we were told to describe a chemical test that can be used to distinguish between an alkanol by the name butanol from an alkanoic acid by the name butanoic acid. So here, the tests that we can do are quite many. Actually, we have 3. The first one being that we can add either sodium carbonate or we can use sodium hydrogen carbonate. If we do these, for the case of butanol, we will see no effervescence because being an alkanol, it will not react with either carbonate or a hydrogen carbonate. But for butanoic acid, being an acid, it would react with the carbonate or the hydrogen carbonate to produce carbon dioxide, and therefore we shall see effervescence or bubbles of a colorless gas. Second test, we can use acidified potassium manganate 7. As we all know, this is usually purple. In the case of butanol, the acidified potassium manganate 7 would change color from purple to colorless. But In the case of butanoic acid, the purple color of acidified potassium manganate 7 would persist or would remain purple. Third test that we can do to differentiate between the two is that we can use or add acidified potassium dichromate 6. In this case, for butanol, the orange acidified potassium dichromate 6 would change to green. But for butanoic acid, the orange color of acidified potassium dichromate 6 would persist or would remain orange. With that, we maintain the same year 2015. Question number 22. Study the flowchart below and use it to answer the questions that follow. So this scheme begins with maize flour, which undergoes process T to give ethanol. Process T is simply fermentation. When we get ethanol here, we react it with concentrated sulfuric 6 acid, which dehydrates it to obtain here ethene and water. Dehydration means we shall remove elements of water from the ethanol. Going up, we introduce an oxidizing agent here, which will oxidize our ethanol to V, which now becomes ethanoic acid. When you oxidize an alkanol, you get the corresponding alkanoic acid. Now this acid, we shall react with the alkali sodium hydroxide to get a salt here, which we call sodium ethanoate and water. So that is what goes on in the flowchart. Now we can answer our questions. We are told to name process T, and process T is fermentation. 2, we are told to give the formula of W. W is sodium ethanoate. Sodium ethanoate has the formula CH3COONA, sodium ethanoate. And then finally, we are asked to give 2 uses of X. X is ethene, and ethene has so many uses, which may include monomer in polyethylene production. That use is quite obvious. We also use ethene to ripen fruits and even vegetables. We can also use ethene as a refrigerant. We were asked only 2, and we would choose between those 3. We are still on the year 2015. We proceed to look at question number 28 of the same year. State one source of alkenes. Alkenes can be obtained from quite a number of sources. We have crude oil, we have natural gas, and we can obtain alkenes also from biogas. The examiner wanted us to just state one source, and any of those would do. Part B, ethane gas was reacted with 1 mole of bromine gas state one observation made during this reaction. So here we expect that substitution reaction took place, and for that matter, depending on the concentration of your bromine gas, either the brown, the red, the orange, or the yellow, and these color shades depend on the concentration of the bromine gas. So all these are acceptable. Color of bromine changes to colorless. This would take place because ethene and bromine would undergo substitution reaction. We now cross over to the year 2016, where we look at question number 13. We are told to draw the structure of compound N. Compound N is our product here, having been formed together with 2 N moles of water. Now, this reaction is a bit complicated, but any student who has undergone what we call organic chemistry 2 under the section of polymers, you should realize that these 2 monomers actually produce our polymer, which has the name nylon 6,6. It is called nylon 6,6 because our 2 monomers here, if you can count the number of carbons in the first one here, they are 6. The number of carbons in the second one here, we have 4 for the bracket, 5, 6. So the polymer here is normally named based on the number of carbon atoms that the 2 monomers have. So our polymer is a nylon 6,6. Now, the 2 monomers, the first one has a name of hexane 1,6 amine, and the second one here has a name of hexane 1,6 dioic acid. So when you take N of hexane 1,6 dioic acid and N molecules of hexane 1,6 diamine, you end up getting polymer nylon 6,6, and of course with elimination of a few water molecules. And that is why this process is normally called condensation polymerization. Now, we want to draw the structure of our polymer, and it is quite easy to do. What a candidate should take note of is this hydrogen here will combine with this HO or OH here to form water. The same will happen to this terminal hydrogen combining with the OH at the terminal end of the second monomer to form another water molecule. What has remained for the first monomer and what has remained for the second monomer are then joined together to form the polymer. So we shall have, there was no space for drawing, so allow me to squeeze it here. We shall have, let's check here, we now have N, because this H has been used with the OH to form water. So we now have N remaining linked to H up here. Then we move here, we have CH2 appearing 6 times. We proceed here, N linked to H, and then this N now we shall link now to the remaining part of monomer 2. So from N we move all the way to C, covalently bonded to oxygen via double bond. Then we proceed to CH2 appearing 4 times here. Then we finally have carbon here, again covalently linked to oxygen via a double bond. That marks the end of our polymer, so we close and put N outside the bracket. That is the easier way of obtaining our polymer from the two monomers. Quite easy for a student to follow. So this becomes our answer for 1 mark, the structure of nylon 6,6. Part B, we were asked to give one of its uses. So nylon 6,6 can be used to make ropes. We also use it to make fishing nets. We also have stockings made out of nylon, what most of us would say or would call undergarments. Any one of those would earn our candidates the next 1 mark. So I want to state here that we normally get fear when we see complicated structures like this one drawn. But I want to tell our candidates they are actually very easy to navigate through. So when you see a huge formula of an organic structure drawn next time, please do not fear. Just approach it with the knowledge that you have. Let's then proceed to 2016, question number 21. Draw and name the isomers of pentane. This is an alkane with 5 carbons, and because we have been awarded 3 marks, we were expected to draw at least 3 isomers. We begin with the straight chain one, where we have 5 carbons in a straight chain. And of course, being an alkane, all of them will be linked via single covalent bonds, and the rest become hydrogen atoms. Next, we need to create a branch using one of the CH3s, either the terminal one or the one that begins here. That would shorten our chain by 1 carbon, so our new isomer would have only 4 carbons. And our branch, the methyl group, would attach itself on carbon 2 from the end, and then the rest become hydrogens. This would be the next isomer, and we shall call it 2-methyl butane. Of course, the name of this one is pentane. The third isomer would be obtained from the second one, where again we create another branch using the terminal carbon on the left. This would now leave us with only 3 carbons on the straight line, then a methyl group on carbon 2, another methyl group on carbon 2, and the rest being hydrogens. This would then be called 2,2-dimethyl propane. So each of the structures have a mark, and each of the names have a mark, giving us a total of 3 marks. We proceed to now the year 2017, where we begin with question number 5. So in question 5, we are told the setup in figure 2 was used to prepare a sample of ethane gas. We are then asked to study it and answer the questions that follow. So for us to prepare ethane, ethane is an alkane with 2 carbon atoms. We need to react soda lime with a sodium salt that has the general name of sodium alkanoate. But to be particular, because we are preparing an alkane with 2 carbons, the sodium salt should have 3 carbons, and that gives it the name sodium propanoate. So we shall heat the mixture and then we collect ethane over water. So we are told to name B, and the name is sodium propanoate. We allow formula CH3CH2 COONA, or the first part can be condensed to C2H5 COONA. Then part B is asking us to write an equation for the complete combustion of ethane. Ethane has the formula C2H6. Reacting with excess oxygen, we shall form carbon 4 oxide and water. And of course, we balance with a 2 on ethane, 7 on oxygen, 4 on carbon 4, and 6 on water. Of course, this equation being organic in nature, the state symbols are not a must. Uses of ethane, we've discussed this earlier. We can use it as fuel to produce ethene through what we just called steam cracking, and we can also obtain hydrogen from ethane. We end the video by finally looking at question number 20 of the year 2017. So question 20 is still giving us a flow chart which we are supposed to study and answer the questions that follow. We begin from the end so as to be able to move backwards, because the information we have here is not very complete. So we have sodium ethanoate here, which we get when we react sodium carbonate with substance K. Substance K is obviously ethanoic acid. Alkanoic acid will react with the carbonate to give the salt, sodium ethanoate. Then we are now obtaining ethanoic acid from ethanol. Process J now becomes oxidation. And for us to oxidize ethanol, we are using our usual oxidizing agents, acidified potassium manganate 7 or acidified potassium dichromate 6. The examiner was not able to give us much information down here, so we cannot tell what was happening unless some corrections were made. So for purposes of this illustration, let's assume that here we introduce concentrated sulfuric 6 acid to dehydrate the ethanol so that our L becomes ethene. That is something that we've just added but was not originally in the paper. Now, to the questions. Identify K and L. K, ethanoic acid, as we've just discussed, and of course we allow you to use symbols as well, CH3COOH. L is ethene, and again we allow symbols C2H4. Name one reagent that can be used to oxidize the alkanol. We have talked of acidified potassium manganate 7. Of course, when you are doing this candidate, use words, or we can also use acidified potassium chromate or dichromate 6. With that, we've come to the end of our video where we have reviewed the testing of the topic organic chemistry for the years 2013 to 2017. We thank you for your time and kindly keep it the Kenyan Teacher for more insightful reviews.